Our today's topic is using several pulleys in two blocks. In our previous video, what we have discussed about the part using one fixed pulley and other movable pulleys. This part we have already discussed in our previous video, and in this video we are going to discuss about the second part, and this part will be the last part of this chapter, that is the third chapter of machine. Okay, so let's start. In this system of pulleys, two blocks of pulleys are used. See here, let me show you the diagram first. We can see here two blocks are there. This is the upper block and this is the lower block. In the upper block we can see here three pulleys are there, and in lower block two pulleys are there. This is another diagram. Two upper block and two pulleys are in lower block. So what is written here? Used one block, that is upper, having several pulleys is attached to a rigid support, that is fixed, and the other block having several pulleys is movable. See, the upper part of this system, block and tackle system, the block is the arrangement of pulleys and the tackle is a rope only. Okay, that's why it's known as block and tackle. The upper part is actually fixed and the lower parts are movable. Both the system, the upper parts are fixed and lower parts are movable. Okay. Having several pulleys movable. This arrangement is called the block and tackle system. The number of pulleys used in the movable lower block is either equal to or one less than the number of pulleys in the fixed upper block. This is very important, very important. The number of pulleys used in the movable lower block is either equal to or one less than the number of pulleys. See here, we can see here two types of diagram are there. The lower block always has to be less than the upper block or it can be equal. This is the main thing. मतलब ऊपर में जो जितना भी पुली होगा नीचे से वो ज़्यादा रहेगा, अदरवाइज इक्वल रहेगा. बस दीज आर द मेन कंडीशन इन केस ऑफ ब्लॉक एंड टैकल सिस्टम. मतलब ऊपर ज़्यादा पुली नहीं रहेगा, दैट यू हैव टू मेक श्योर. A strong inextensible string that we have already inextensible का मतलब क्या है, that we have already discussed in our previous each and every video. Whenever we have started to know about the machines, that is pulley, so that time we have already discussed what is inextensible. Inextensible means the rope does not stretchable. The rope actually has to be very strong and it should not be stretchable. A strong inextensible string or rope of negligible mass passes around all the pulleys. One end of the string is attached to the hook of the lower block. This is another important topic. See here, one end of the string is attached to the hook of the lower block if the number of pulleys in the upper block is more than that in the lower block, or it is attached to the hook of the upper block if the number of pulleys is equal to in both the blocks. One condition we have, only one condition, either the lower pulleys has to be less than the upper pulleys, and or you can say that number of pulleys in upper has to be equal with the number of pulleys in lower section. So if the number of pulleys are more than lower section, what we can see here, the number of pulleys in upper section is more in case of lower section. In that case, the end part of the hook, see, connected in the lower part, and if the number of pulleys in upper section are equal to the number of pulleys in lower section, then the end part of the string will be connected to the upper part of the pulley. This is very important and we can easily understand the thing, that you have to make sure. ये rope जब भी pulley में देना है, at that time इट्स वेरी सिंपल. देखो ये रोप यहाँ से आ रहा है, एकदम बाहर से आ रहा है, फिर इसमें, फिर इसमें, उसके बाद यहाँ से इधर आ रहा है. मतलब नीचे का जो ब्लॉक सिस्टम है उधर कनेक्ट हो रहा है नीचे में, और इसमें क्या हो रहा है, ये जो रोप है बाहर से आके इधर आके ऊपर का पुली में अटैच हो रहा है. So this is the main system that is written here. Again I am reading the same thing. See here. Where is it? Or it is attached to the lower hook. One end of the string is attached to the hook of the lower block if the number of pulleys in the upper block is more than that in the lower block, or it is attached to the hook of the upper block if the number of pulleys is equal in the both the blocks, so as to apply the effort in the downward direction. Okay, fine. See here, 3.25 shows a block and tackle system of 5 pulleys in which one end of the string is attached to the hook of the lower block, that we can see here. One end of the attached to the lower block, one end of the string is attached to the lower block. And 3.26 shows a block and tackle system of 4 pulleys in which one end of the string is attached to the hook of the upper block, that we have discussed. See here. Now the tension along the entire length of the string is same and is denoted as T. Entire length of the string is same. The tensional force, the entire string is same. The mechanical advantage. What will be the mechanical advantage? The tension of 5 segments of string supports the load, therefore L equals to 5T. The tension in the 5 segments in this 3.25, see here 3.25, there are 5 number of pulleys. Let me count. From the load side, this is 1, this one is 2, this is 3, this one is 4 and 5, and this one is for effort. This tensional force is for effort. So in case of, in the side of load, there are 5T. So we can simply write L equals to 5T, and that is the thing that it's written, and E equals to T. E equals to T means effort is equals to only 1T. Hence E will be L by 5. E will be L by 5. Why? As L equals to 5T, L equals to 5T, then T will be equals to L by 5. That's why E equals to L by 5 by substituting the value of T. Okay, now mechanical advantage will be what? Mechanical advantage, as we know that load upon effort, the ratio between load and effort. So load is 5T and effort is L by 5. Hence effort is L by 5, it's not L by 5, we have to write T. So 5T by T, mechanical advantage will be 5, as we have 5 pulleys. Similarly, in figure 3.26, that means in this figure there are 4 pulleys, so load will be 4T, load will be 4T and E will be T. Here also mechanical advantage will be 4. So in general, what we have seen, that if the total number of pulleys used in both the blocks is N and the effort is applied in the downward direction, then the tension in the N segments of string supports the load. Therefore L will be equals to NT. So L equals to 5T in case of 5 pulleys, L equals to 4T in case of 4 pulleys. That's why L equals to NT. Very simple thing. N is the number of pulleys. Okay, and E equals to T. This is fixed. From here we can write E equals to L by 9. Thus, effort required to balance a load. Effort. What is the effort to require balance a load? Effort will be equals to L by number of pulleys. This is the thing. This is the actual mathematical expression of effort that we have already seen. So thus in a block and tackle system the effort gets multiplied n times, where n is the total number of pulleys in the system. N is the total number of pulleys, and therefore it therefore acts as a force multiplier. Load is 4L, but effort is only T, or simply E. 4L means load is, sorry, what happened to here? Okay. Everything is fine? Yeah. Load is 4T and effort is only T. So we can see that number of pulleys are multiplying with the tensional force, and that is the thing written over here. Let me check, where n is the total number of pulleys in the system. It therefore acts as a force multiplier. Hence mechanical advantage load upon effort n into T by T equals to n. That means if there are 5 number pulleys, mechanical advantage will be 5. If there are 4 number of pulleys, mechanical advantage will be 4. That's why mechanical advantage will be depending on the number of pulleys in case of block and tackle system. Total number of pulleys in both the blocks. Yes. Now velocity ratio. In a system of n pulleys, if the load moves up through a distance d, each segment of string supporting the load is loosened by a length d. So the effort and the moves through a distance nd. That is, if dl equals to d, then d equals to nd. dl means displacement due to load, that is only the displacement, and displacement due to the effort will be 5 times or 4 times depending on the pulley. That's why it is written nd. Hence velocity ratio will be displacement due to effort upon displacement due to load. So displacement upon effort is nd and displacement due to load is d, then it is n. So what we can see here, that the mechanical advantage and velocity ratio both are n, that is number of pulleys will be dependent in case of block and tackle system. Now the efficiency is mechanical advantage by velocity ratio. So mechanical advantage is n and velocity ratio is only n, that's why it's 100% 1. The efficiency is 100% only in the ideal machines, only in the ideal situation, but in actual practice there is always some friction that we have already discussed in and every pulley system. See, that means 100% efficiency we are not getting, we are getting less than 100%. So all machines are not ideal, that's why, because of we are not getting 100% system, because there are lots of friction. The friction may be between the bearing and the shaft, the friction may be on the others arrangement of the part. Okay, so bearings of the pulleys and the weight of the string along the weight of the lower block with pulleys is not negligible, so the mechanical advantage decreases and hence the efficiency decreases. Done. So note, the pulley system is only a force multiplier, the pulley system only a force multiplier, and just like other machines there is no gain in energy. This can be seen as follows: the work done by the effort or input energy equals to effort into displacement. See, these are the first things that we have seen. E into nd, that is NED. The work done by effort, that is input energy, effort into distance moved by the effort. E into N into D. The work done on the load into distance or displacement moved by the load, that is L into D. So mechanical advantage is, so thus there is no gain in energy, it's just a force multiplier. Effect of weight of pulleys on mechanical advantage, velocity ratio and efficiency. What are the effect of weight? पुली का जो वेट है ना, उसका क्या इफेक्ट है? अभी तक हमने जो वेलोसिटी रेशियो, मैकेनिकल एडवांटेज, जो भी मैथमेटिकल एक्सप्रेशन जो भी हमने निकाला, उसमें पुली का वेट हम लोगों ने इंक्लूड नहीं किया था. नाउ if the weight of the pulley is maximum, then what will happen? See, consider a system n pulleys. Let W be the total weight of the lower block along with the pulleys. नीचे का जो ब्लॉक सिस्टम है उसमें टोटल जो वेट है वो W है with the pulley. In the balanced position, what will happen? That means effort will be T, and the load will be L plus W. L plus W, that is equals to N into T. Load will be equals to N plus W. N means number of pulleys और W is the weight of the pulley structure. पुली का जो structure है, that is written here, N into T. So L equals to NT minus W. Hence NE minus W. NE minus W, why? As because of N is the number of pulley and E is the effort. That's why it is written here E equals to T. So NT minus W. See, from this equation we are simply getting this equation. L plus W equals to N into T. Hence load is equals to NT minus W, or we can write NE minus W. I hope it's clear to you. If not, you can ask me in comment section anytime. Okay, so thus the mechanical advantage is less than the ideal value N. See here, what will be the value of N, and it will be subtracted by this value, that is weight of the pulley by effort. A ratio is there, मतलब weight जो कि पुली का जो weight है और जितना effort हम लोग दे रहे हैं उसका जो ratio है उससे कम होगा. So efficiency is less than value. The velocity ratio does not change, it remains N. मैकेनिकल एडवांटेज, ये जो मैकेनिकल एडवांटेज वो कम होगा इनसे, लेकिन वेलोसिटी रेशियो दैट विल बी रिमेन सेम. वेलोसिटी रेशियो इज इक्वल्स टू N. हेंस देखो, दीज आर द कंडीशन व्हेन वी इंक्लूड द वेट ऑफ द पुली, दैट वी हैव टू अंडरस्टैंड. मैकेनिकल एडवांटेज, वेलोसिटी रेशियो विल बी सेम in case of block and tackle system, and if there are one fixed pulley and other are movable, at that time mechanical advantage will be power. Okay, 2 to the power n, 2 to the power n will be the number of pulleys. Let me show you again. See here, the mechanical advantage in case of in case of one is fixed and another is using one fixed pulley, another is movable. Mechanical advantage is 2 to the power n. Similarly, velocity ratio is also 2 to the power n, but here the n will be multiplied in case of block and tackle system, and in this part we are including the weight of the pulley. At that time velocity ratio will be only n, but mechanical advantage will be less than n. Hence efficiency will be mechanical advantage by velocity ratio n minus Wv by n, as because of efficiency. From this calculation we are getting this mathematical expression, and this is the very important part from the whole chapter. It's a very important part. So thus the efficiency is reduced due to the weight of the lower block of pulleys. More the weight of the lower block, less the efficiency. For greater efficiency, the pulley is the lower block should be as light as possible, and the friction in bearing of pulleys should be minimized in the use of lubricants. That's why we generally used lubricants in case of pulley system, that may be block and tackle, that may be one fixed and other are movable. So we have to use some lubricants so that we can reduce the friction, we can reduce the weight of the pulley. So these are the all part about this chapter, and thank you all.